All right, so the last lesson in Unit 5 is about oxidation and reduction reactions. I don't consider this one of the major types because technically single displacement reactions, double displacement reactions, even combustion reactions are oxidation reduction reactions. So this is more a kind of a way of recognizing what's going on with the electrons when these reactions take place. So this is a good slide to take some notes on. It's the definitions, all right? And then what I've done is these are actually half reactions. So the overall reaction that you would see here would be something like this would be an example of a single displacement reaction that does this. So you've got zinc plus, say, sodium chloride yields copper and zinc chloride. All right, so this would be the full reaction. This happens to be a single displacement reaction. But what's going on electron-wise is your zinc is oxidizing. All right, so zinc is going from its solid form with a neutral amount of protons and electrons to giving away, losing some of those electrons and becoming an ion. All right, so oxidation, I remember what's going on with oxidation with this little trick here. Leo, lose electrons, oxidation. Right? The other metal element in this single displacement reaction is going through what we call reduction. Right? And that element is gaining the electrons that zinc lost. Right? So copper went from being an ion. All right? It picked up these electrons that zinc gave up and became copper solid. All right? And I remember that with Gur. Gains electrons reduction. All right? So Leo the lion goes Gur. Leo, lose electrons, oxidation. Gur, gain electrons, reduction. All right, and that's what you'll have to do, is be able to spot out, okay, which element is going through oxidation, which one's going through reduction. So, for example, if you look here, we would say that magnesium is the reaction that was oxidized. Before I explain, see if you can, in your own words, explain why are we saying magnesium was oxidized. See if you can, work out that half reaction. All right, so Mg went from being just a solid magnesium to being Mg2+, and the only way it can do that is by giving off 2 electrons. All right? The next question to you is, which element was then reduced? Who gains those electrons? All right, and you'll be able to tell because which metal became your solid. All right, so we went from Na+, you got 2 Na+, 2E-, makes 2 Na. All right, so oxidation, reduction. You won't necessarily have to come up with these on your own, but you've got to be able to look at this reaction and see that, oh yeah, Mg went from being neutral to being positively charged, so it lost electrons. Sodium went from being positively charged to neutral, so it gained electrons, and be able to then remember Leo, Gur. Lose electrons, oxidation, gain electrons, reduction. All right, so let's practice that a little bit. How about this top reaction up here? Which element is being oxidized? This one's broken up for you so you can kind of see what's going on charge-wise. So what does oxidation mean? So which element is losing electrons? All right, if you need to, kind of pair things up. So we've got silver, going from neutral to +1. You've got copper going from +1 to neutral. And then you also have chlorine, which is going from -1 to -1. So I can say chlorine definitely not getting oxidized. All right, but which one is losing some electrons? Remember, electrons are negatively charged, so we're giving away a negative charge. Silver. All right. If you have a positive charge, that means that you have more protons than electrons. You had to lose some electrons to get there. All right. How about for the second set, which is reduced? Pause the video if you need some more time to figure it out. But again, reduced, I'm looking for something that is gaining electrons. All right. Aluminum, that's Leo, it's losing electrons. Iron is going from positive to neutral, right? So if it's losing some positive charge, so to speak, or it's being canceled out by negatives, that's gaining electrons. All right, and then you can also just confirm that it's definitely not oxygen because oxygen doesn't change. All right, so B, iron, is the one that's being reduced. So this, sometimes you'll be given the charges on things, other times you might have to determine what the charge is. And again, that comes from the known charges on our periodic table. All right, so if you're asked to determine the oxidation number, that is asking you what is the charge. So for example, this compound K2Cr2O7, you might be asked, well, what is the oxidation number of chromium? Just one of the CRs. All right, overall, there's no charge written on this formula, so this is neutral, which means the charge is 0 when you combine all the element charges together. So what we can do to figure that out is break this up. I know that potassium is +1, so I've got 2 positive potassiums. And I know that oxygen is 2-, so I have 7 O2-. All right, which means I have +2 in there from my chromiums, -14 in there from my potassiums, -14 in there from my oxygens, and then I have 2 Cr2s. All right, so my 2 CRs have to give me a total of, +12, right? Because if I combine what I've got here, I've got -12 going on right now because of all those oxygens. The only way I'm going to cancel that out and get to 0 is if my chromiums add up to +12. And since there's 2 of them, 1 CR would be +6. All right? So, you might want to jot this down, come in handy for your quiz, and let me know if you have questions.